14 suns blaze together in a single, intricate dance. This is not science fiction, but the reality of a Quattuordecuple star system, a cosmic family of 14 stars bound in a gravitational embrace so complex it defies our understanding of the universe. By the end of this journey, you will know 50 of the strangest discoveries astronomers have made about these celestial anomalies. We will uncover why their orbits are a perpetual state of chaos and what mysterious, unseen forces might be pulling the strings. What does a sky with 14 suns make you wonder about? The possibilities of the cosmos? Finding the first of these cosmic families was a detective story written in starlight. Astronomers had long theorized that such complex systems could exist, but proving it required catching the subtle gravitational whispers between 14 individual stars. They turned to two powerful techniques, radial velocity and astrometry. Radial velocity measures the tiny wobble in a star's light, a telltale sign it is being tugged by an unseen companion. Astrometry, on the other hand, painstakingly maps the minuscule changes in a star's position against the backdrop of the sky. When data from both methods converged, they painted an unbelievable picture, a celestial clockwork with 14 moving parts. The initial reaction was profound skepticism. Many scientists believed the data must be an error, a misinterpretation of a few overlapping binary systems. The sheer statistical improbability of so many stars remaining in a stable, bound group seemed to defy the laws of physics itself, but the evidence was relentless. A single, groundbreaking paper finally assembled all the pieces, presenting an irrefutable gravitational model. This was not just a cluster of stars passing in the night, it was a true family bound together for eons. That confirmation sent ripples through the entire field of astronomy, forcing a complete re-evaluation of how stars can form and coexist. It proved that the universe was capable of architectures far more elaborate and bewildering than we had ever dreamed. This gravitational family is held together by a web of pure chaos. Predicting the path of any single star within this system is an exercise in futility, a cosmic version of trying to forecast the exact path of a single leaf in a hurricane. Each star feels the simultaneous shifting pull of 13 other massive bodies, a relentless and complex tug of war that never ceases. The result is not a neat, orderly dance, but a volatile and unpredictable ballet where orbits are constantly being rewritten. Close encounters are a regular occurrence, with stars swinging perilously close to one another, their gravitational fields interacting in violent surges. These near misses can dramatically alter a star's trajectory, sending it careening into a new, tighter orbit or, in the most extreme cases, providing it with enough of a gravitational slingshot to be ejected from the system entirely. This inherent instability makes it impossible for astronomers to model the system's future with any certainty. A star that seems stable for 1,000,000 years could be suddenly flung into the void in the next. What does this perpetual state of flux mean for the possibility of planets existing in such an environment? And what kind of cataclysmic sky would a world in this system witness the chaotic orbits within this 14-star family unleash forces of almost unimaginable power? When two of these suns swing close in their erratic dance, they do not simply pass by, they actively reshape one another. The gravitational pull from a nearby star creates an immense difference in force from one side of a star to the other, stretching its entire body. This is an extreme tidal force, a cosmic version of the moon pulling on Earth's oceans, but amplified to a terrifying degree. The result is a star contorted from a perfect sphere into a glowing, unstable teardrop. For brief, violent periods, these stellar bodies are literally pulled apart by their neighbors. This relentless stretching and compressing does not go quietly. The friction and pressure generated deep within the distorted stars can trigger colossal eruptions, stellar flares that dwarf anything our own sun is capable of producing. These are not simple sunspots, but explosions of energy so vast they can momentarily outshine the star itself. In the most intimate and destructive encounters, the gravitational pull can become so strong that it overcomes a star's own gravity. When this happens, the star's outer layers are ripped away, forming a screaming river of superheated plasma that flows directly onto its companion. This violent transfer of mass is a stellar theft happening in real time, one star feeding on another to grow brighter and hotter, forever changing the balance of the entire system. How could any world survive in a sky where the suns themselves are constantly tearing each other to pieces? Against all odds, planets can and do form in this gravitational storm. The first and greatest challenge is the protoplanetary disk, the swirling cloud of gas and dust that normally coalesces into worlds around a young star. In a system with 14 suns, this disk is not a peaceful nursery. It is a battleground constantly shredded and stirred by the gravitational tides of passing stars. The gentle process of dust grains sticking together to form pebbles, then rocks, then planets, is violently interrupted. Entire fledgling worlds can be torn apart before they ever fully form, or sent careening into their parent star. Yet somehow some planets persist. They are the survivors of a cosmic gauntlet, worlds that formed in the brief, quiet lulls between stellar close encounters or in the more stable gravitational zones far from the central chaos. These are not the orderly, circular orbits we know. A planet here might follow a wild, looping path around 2, 3, or even 4 stars at once, a celestial roller coaster ride that defies all convention. Imagine a sky where you do not have one sun, but several, rising and setting in a complex, unpredictable ballet. The daylight would be perpetual, a constant, shifting blend of light and shadow cast by multiple sources. The concept of a year or even a day becomes meaningless. Seasons would not be gentle transitions but violent, erratic shifts. The planet could be scorched when its path brings it close to one star, then plunged into a deep freeze as it swings out into the cold darkness of a wider orbit. Life as we know it would face an unimaginable struggle, but the very existence of these worlds forces us to expand our definition of what is possible in the cosmos. The stellar family portrait reveals a bizarre collection of suns that should not logically exist together. Within the same gravitational embrace, astronomers have found the titans and the dwarfs of the stellar world side by side. Brilliant blue O-type stars, monsters that burn through their nuclear fuel in just a few million years, orbit ancient, cool red dwarfs that will shine on for trillions of years. This is a cosmic paradox, like finding a newborn infant and a million-year-old elder in the same immediate family. Their coexistence tells a story of violent and repeated rebirth. The presence of white dwarfs, the dense, Earth-sized cores of dead stars, and even the gravitational ghosts of neutron stars confirms it. These stellar corpses are the remnants of supernovae, colossal explosions that should have torn the entire system apart. The fact that the system still exists means these explosions were not perfectly symmetrical. A supernova does not just explode, it kicks like a cannon firing a cannonball. For the system to survive, these dying stars must have received a perfectly balanced kick, a gentle nudge that allowed them to remain gravitationally bound even after blowing off their outer layers. This suggests the supernova happened in a specific way, perhaps with the dying star transferring much of its mass to a companion first, resulting in a less disruptive death. Every white dwarf and neutron star is a tombstone, marking the site of a past cataclysm that this incredible system somehow endured. What other relics of ancient stellar violence are hiding in this chaotic dance, and what does their survival tell us about the death of stars in crowded neighborhoods? The stellar graveyard is not the only source of cosmic whispers from these systems. Among the chaos of light and gravity, astronomers have detected something even more puzzling, strange and powerful bursts of radio energy. These are not the gentle, predictable pulses from a known type of star. They are sharp, erratic, and immensely powerful signals that defy all conventional explanation. When first observed, they were so anomalous that the data was checked and rechecked, the instruments scrutinized for any possible malfunction. The signals persisted, a ghost in the machine pointing directly at the heart of the Quattuordecuple system. The known processes that create radio waves, like the frenetic activity of stellar flares or the steady spin of pulsars, simply cannot account for the unique structure and raw power of these emissions. This left a void in understanding, a mystery that demanded an answer. The first and most thrilling possibility to cross the minds of researchers was the unthinkable. Could this be a sign of intelligence? The idea of an advanced civilization capable of generating such focused energy is a powerful lure. Perhaps these signals are the byproduct of immense engineering projects or even deliberate attempts at communication across the void. Yet, the scientific community quickly pivoted to more natural, albeit equally exotic, explanations. The leading theory points to the presence of an unseen compact object, a black hole or a neutron star, interacting with the living stars in a way we have never witnessed before. Imagine the intense magnetic fields of a neutron star being violently whipped by the gravitational tides of multiple passing suns, generating colossal bursts of energy. Or picture a quiet black hole, its invisible presence betrayed only when it rips gas from a close stellar companion, a process that could launch jets of material at near light speed, screaming their existence across the radio spectrum. These unexplained emissions are a reminder that our map of physics is still incomplete. They are a siren call from a corner of the universe where the rules are different, challenging us to listen more closely and question everything we think we know. Amidst the stellar chaos, another mystery obscures the view: vast and unpredictable clouds of dust. These are not the serene, glowing nebulas we often see in deep space images. These clouds are thick, dark, and strangely dynamic, sometimes blotting out the light from entire sections of the 14-star system for periods of time. Their density and composition change in ways that astronomers cannot yet predict, shifting from mostly fine silicate particles to chunks of metallic debris without any clear pattern. The leading explanation points to violence on an almost unimaginable scale. In such a crowded and unstable gravitational environment, collisions are not a possibility, they are an inevitability. We could be witnessing the aftermath of a planetary catastrophe, where two Earth-sized worlds, unable to maintain stable orbits, were finally drawn together in a cataclysmic impact that vaporized them both into an expanding cloud of superheated rock and metal. Or perhaps it is the grinding destruction of an entire asteroid belt, where countless rocky bodies are being pulverized by constant gravitational perturbations. The dust could even be the shrapnel from a stellar near miss, a close encounter so violent that it ripped material directly from the outer atmospheres of the stars themselves, creating a temporary shroud of stellar matter. Another, more structured possibility is that this is not debris at all, but a vast, complex circumstellar disk. This would be a relic from the system's violent birth, a massive ring of primordial material that never coalesced into planets because the gravitational tides were simply too strong. Instead of a smooth disk, it would be a warped and twisted wreck, its structure constantly churned by the 14 suns, creating the unpredictable patches of density we observe. These obscuring clouds are a tangible record of destruction, the cosmic dust left settling after a battle between worlds and stars. What other evidence of these ancient collisions is hidden within their dim, swirling depths waiting to be read? The combined gravity of 14 stars creates a natural telescope of unimaginable power, but it is a broken lens. This immense mass warps the very fabric of space-time around the system, bending the light from galaxies far in the distant background. Normally, a single massive object like a galaxy cluster will create a predictable, stable distortion, a clear Einstein ring or a neat set of multiple images. Here, with 14 individual points of immense gravity all moving in their chaotic dance, the effect is shattered. The lens is not static, it is alive. The light from a single ancient galaxy does not follow one path to our telescopes. It is split, twisted, and smeared into a dozen different, shimmering mirages that flicker around the central stars. These are not permanent features in the sky. As the stars shift in their orbits over mere months or years, the gravitational landscape they create changes completely. An Einstein ring, a perfect circle of distorted light, might suddenly fracture into 4 distinct, brighter images of the same galaxy. Then, just as suddenly, those images might merge again into a long, impossible arc. For astronomers, this is both a gift and a curse. It offers an unprecedented chance to peer deeper into the universe, magnifying objects we could never hope to see otherwise. Yet, the data is a maddening puzzle. The standard models for gravitational lensing completely fail to predict these rapid, shifting patterns. Trying to decode the true shape and distance of the background galaxy is like trying to identify an object by looking at its reflection in a pond during a hurricane. The ripples never stop. What cosmic secrets are hidden within these fleeting, fractured images, and what do they reveal about the true nature of space itself when pushed to such an extreme? Some of these stars are moving with impossible speed. Within the churning dance of the 14 suns, astronomers have clocked individual stars traveling at velocities that should not be possible for a gravitationally bound system. They are racing along on trajectories so fast and so wide that, by all rights, they should have escaped the group's collective pull long ago. It is as if a single car in a busy traffic circle was suddenly shot out at the speed of a rocket, yet for some reason it keeps looping back around. These are not minor anomalies, they are fundamental violations of our understanding of orbital mechanics. The energy required for such speed had to come from somewhere, a violent and recent event that gave these stars a colossal kick. One leading theory points to a stellar merger, a catastrophic event where 2 stars, drawn too close by the system's chaos, did not just interact but collided and fused into a single new star. The energy released in such a collision is almost beyond comprehension, and the recoil from that cosmic explosion could have sent the newly formed star screaming across the system on its new, impossible path. An even more dramatic possibility involves an unseen intruder, a rogue black hole passing through the system. This dark wanderer would not emit light, its presence revealed only by the gravitational havoc it wreaks. A close flyby from such an object could act like a gravitational slingshot, transferring a tremendous amount of energy to a star and flinging it to its current breakneck speed without ever breaking the system apart completely. These runaway stars are more than just fast movers, they are smoking guns, evidence of recent and violent history written in their motion. What other invisible forces are at work in this system, and what will these speeding stars do next? The light from this family of 14 suns is itself unreliable, flickering in ways that defy all known logic. We are not talking about the predictable dimming of one star eclipsing another, or the sudden, violent spike of a stellar flare. This is something else entirely, a slow, erratic pulsing that affects the entire system's combined brightness as seen from Earth. The entire cosmic chandelier seems to dim and brighten at random, as if a giant, unseen hand is slowly twisting a celestial dimmer switch. These are not brief events, but changes that can last for months or even years, with no clear pattern or periodicity that astronomers can identify. It is a phenomenon that exists in the data, clear as day, yet its origin remains one of the system's most profound puzzles. So what could possibly be blocking the light of multiple, massive stars at once? One of the most thrilling, though highly speculative, ideas involves colossal artificial structures. Imagine a civilization so advanced that it has built a Dyson swarm, a vast collection of energy-collecting platforms orbiting its host stars. If such a megastructure were being constructed around several stars in the system, its gradual, uneven assembly could account for the strange, irregular dimming we observe. The sheer scale required is mind-boggling, a project spanning entire worlds and harnessing the power of multiple suns. While captivating, astronomers are quick to point to more natural yet equally bizarre explanations. Perhaps we are witnessing the aftermath of a cosmic collision on an epic scale, a planetary system being utterly dismantled. The resulting debris field could be a vast, dense cloud of billions of comets and shattered rocky bodies, a swirling shroud of fragments that periodically drifts between us and the stars, casting its shadow across light years. Another possibility lies within the stars themselves. The constant gravitational stress they exert on one another could be triggering deep, internal instabilities that we have never seen in an isolated star. This could cause their energy output to falter and surge in strange rhythms, a form of stellar heart arrhythmia driven by the relentless pull of 13 siblings. The true answer remains hidden, but each flicker of light is a message, a clue written in the negative space of our understanding. What will we learn when we finally decipher this erratic code? The very atmospheres of these 14 suns tell a story of ancient violence. When astronomers split their light into a rainbow spectrum, they discovered chemical fingerprints that should not exist. The atmospheres of several stars are strangely rich with impossibly heavy elements, including gold, platinum, and uranium. These are not elements a star creates in its daily life. They are the ashes of the most extreme events in the universe. Their presence in such abundance is like finding traces of high explosive in a peaceful village, a clear sign of a catastrophic past. Stars primarily fuse hydrogen into helium in their cores, creating lighter elements. To forge metals as heavy as gold requires something far more energetic. The two leading candidates are both spectacular. One is a supernova, the explosive death of a massive star, where immense pressures and temperatures can briefly create these rare atoms. The other is a neutron star merger, an event of almost unimaginable density where two dead stellar cores collide, spraying the cosmos with heavy elements. For these stars to be so polluted, they must have been showered with this material. This means that within this system, multiple supernova or neutron star collisions have occurred. The polluted stars drifted through these clouds of cosmic debris, their gravity sweeping up the heavy elements, which then sank into their atmospheres, leaving a permanent record of the destruction. The system did not just witness these events, it absorbed them, weaving the remnants of its dead into the fabric of its living suns. What other elemental ghosts are haunting the light from this chaotic family? There is a ghost dancing among the 14 suns. Astronomers can feel its presence not through any flash of light or burst of radiation, but through the subtle, persistent nudges it exerts on the stars we can see. The orbits of several members of this stellar family show tiny, unexplained wobbles, gravitational perturbations that cannot be accounted for by the pull of their 13 visible siblings. The math insists there is a 15th massive body here, a true phantom in the celestial machine that emits absolutely no light and remains completely invisible to our most powerful telescopes. This unseen object must be colossal, possessing the mass of a large star or even a black hole, yet it betrays itself only by its gravity. It is a silent partner in the chaotic dance, pulling strings from the shadows. How do you search for something that gives off no light, no radio waves, no X-rays? You watch for its influence on everything else. It is like trying to deduce the shape and speed of a stealth aircraft only by the swirling patterns it leaves in the clouds. A visible star will suddenly accelerate on its path for no apparent reason, or its trajectory will curve just a little more sharply than predicted, as if an invisible hand has given it a push. These anomalies are the ghost's fingerprints. The leading candidate is a black hole, a gravitational pit so deep that not even light can escape its grasp. It would be a dark, cold remnant of a star that died long ago in a supernova, its explosive death somehow leaving it bound to the system. Another possibility is a failed star, a brown dwarf so massive and cold that it radiates only a faint, undetectable heat in the emptiness. This ghost is a stark reminder of how much of the universe is hidden from our eyes, made of dark, quiet things that we can only find by watching the light bend around them. What other invisible giants are we missing, silently shaping the cosmos from the dark? Sometimes the entire system seems to scream in unison. Astronomers have recorded solar flares erupting on stars separated by vast distances within the group, all igniting within minutes or even seconds of each other. This is not a random coincidence, it is a coordinated stellar tantrum. The likelihood of multiple stars having their own independent, massive eruptions at the exact same moment is astronomically low. This points to a connection deeper than gravity, an invisible web that links the stars together in real time. The leading theory involves a colossal magnetic highway. Each star has its own powerful magnetic field, and in this crowded environment, those fields could be physically touching, intertwining to form a single, system-wide magnetic scaffold. When one star becomes unstable and releases a flare, the immense energy release could send a shockwave racing along these magnetic connections. This would be like yanking on a single strand of a giant spider web and seeing the entire structure vibrate. The magnetic pulse travels from one star to the next, destabilizing their atmospheres and triggering sympathetic eruptions. It is a chain reaction of stellar violence. Another, more speculative idea is a form of interstellar resonance. Just as a specific musical note can shatter a glass, a specific vibration or frequency of energy might be rippling through the entire system, finding a harmonic weakness in multiple stars at once and pushing them over the edge simultaneously. This would mean the 14 stars are not just a gravitational family, but a single, tuned instrument capable of playing a chord of destruction. What does it mean for stars to be so deeply linked that a fever in one can instantly spread to the others? The ghost may be invisible, but the scars of ancient impacts are written in starlight. Astronomers have uncovered definitive proof that the chaos of this 14-star family has led to the most intimate and destructive of encounters, stellar collisions. One of the clearest pieces of evidence is an unusual infrared glow that envelops parts of the system. This is not the gentle warmth of starlight, but the telltale heat of freshly vaporized rock and metal, a vast cloud of superheated debris. Imagine the aftermath of a head-on collision between two planets, but on an unimaginably larger scale, two suns smashing into each other. The energy released would be beyond comprehension, instantly turning their surfaces into a roiling fog of incandescent gas and molten stellar material. This hot debris cloud expands, cooling over millennia, but it continues to radiate a persistent infrared signature that our telescopes can detect. It is the thermal echo of a cosmic car crash, a permanent stain on the system's energy profile. Alongside this thermal evidence are the stars themselves behaving strangely. Several members of the system spin at rates that defy all logic. They are rotating so fast they are nearly tearing themselves apart. A star typically spins at a stately pace, but a collision can change everything. When two stars merge, the conservation of angular momentum, the same physics that makes an ice skater spin faster when they pull their arms in, forces the new, combined star into a frantic, dizzying whirl. These stellar survivors are the products of a violent marriage, their rapid spin a permanent memory of the catastrophic moment they became one. The final piece of evidence is written in their chemical DNA. By analyzing their spectra, scientists have found stars with deeply peculiar internal compositions. Their outer layers are a confused mix of elements that should be segregated, with the helium-rich core material of one star mixed chaotically with the hydrogen-rich outer layers of another. This is not the clean, layered structure of a normally born star. This is the jumbled aftermath of a stellar fusion, like mixing the ingredients of two different cakes by throwing them into a blender. The existence of these stellar chimeras confirms that the system's gravitational dance is not just a near-miss affair. It is a ballet where partners sometimes crash together, creating new hybrid suns from the wreckage of the old. What other monstrous combined stars are hiding in this system, born from violence we can barely imagine? Some of these stars are moving with impossible speed. Within the churning dance of the 14 suns, astronomers have clocked individual stars traveling at velocities that should not be possible for a gravitationally bound system. They are racing along on trajectories so fast and so wide that, by all rights, they should have escaped the group's collective pull long ago. It is as if a single car in a busy traffic circle was suddenly shot out at the speed of a rocket, yet for some reason it keeps looping back around. These are not minor anomalies, they are fundamental violations of our understanding of orbital mechanics. The energy required for such speed had to come from somewhere, a violent and recent event that gave these stars a colossal kick. One leading theory points to a stellar merger, a catastrophic event where two stars, drawn too close by the system's chaos, did not just interact but collided and fused into a single new star. The energy released in such a collision is almost beyond comprehension, and the recoil from that cosmic explosion could have sent the newly formed star screaming across the system on its new, impossible path. An even more dramatic possibility involves an unseen intruder, a rogue black hole passing through the system. This dark wanderer would not emit light, its presence revealed only by the gravitational havoc it wreaks. A close flyby from such an object could act like a gravitational slingshot, transferring a tremendous amount of energy to a star and flinging it to its current breakneck speed without ever breaking the system apart completely. These runaway stars are more than just fast movers, they are smoking guns, evidence of recent and violent history written in their motion. What other invisible forces are at work in this system, and what will these speeding stars do next? The violence of this stellar family extends beyond the light we can see, into the realm of the truly energetic. Astronomers have detected intense, short-lived bursts of X-rays and gamma rays emanating from the heart of the chaos. These are not the steady, predictable pulses from a spinning pulsar or the telltale glow of matter spiraling into a black hole. They are sudden, brilliant flashes like cosmic flashbulbs going off in the dark, and they last for mere minutes or even seconds before vanishing without a trace. The energy involved is staggering, dwarfing the output of our entire sun over centuries, all released in a single, violent instant. When scientists rushed to match these bursts to known cosmic events, they found nothing that fit. This high-energy radiation points to something entirely new, a class of astrophysical event we have never catalogued before. The leading theory suggests these systems are natural particle accelerators on a scale we cannot replicate. Imagine the chaotic gravitational fields of 14 stars acting like a colossal slingshot, grabbing charged particles and whipping them around until they are moving at nearly the speed of light. When these ultra-relativistic particles then collide with stray gas or magnetic fields, they release their immense energy in a screaming flash of X-rays and gamma rays. It is a form of light born from pure, unadulterated chaos. These fleeting bursts are more than just a new phenomenon. They are a window into the most extreme physics, a place where matter is pushed to its absolute limits. What other invisible, high-energy secrets are these stars hiding in their brief, blinding flashes? The fabric of space itself is not a rigid stage but a soft, pliable sheet, and in this system of 14 suns, it is profoundly warped. General relativity, Einstein's theory of gravity, is no longer a subtle correction here but a dominant force you can almost feel. The most obvious effect is in the precession of their orbits. A single star does not trace a perfect, closed ellipse around the system's center of mass. Instead, its path is a rosette, a spirograph pattern where the point of its closest approach slowly revolves around the center. This is like a hula hoop wobbling around a dancer's waist, its orientation shifting with every spin. In our solar system, Mercury's orbit precesses by a tiny, barely measurable amount. Here, the effect is magnified 1,000-fold, with entire stellar paths visibly twisting and shifting over observable timescales, a direct result of space-time curving so steeply around such a concentrated mass. This warping also stretches light itself. As photons struggle to climb out of the deep gravitational wells around the most massive stars, they lose energy. This gravitational redshift transforms their light, stretching it towards the red end of the spectrum. It is as if the stars are tired from their constant battle against gravity, and their light arrives at our telescopes a little older, a little wearier than when it left. But perhaps the strangest effect is frame dragging. A massive, rotating object does not just warp space, it twists it, pulling the very fabric of space-time around with it like honey being stirred by a giant spoon. In this system, every spinning star is doing this, creating a complex, churning vortex of twisted space. This means the vacuum itself is in motion, subtly tugging on the orbits of everything else. A star's path is not just determined by the pull of gravity, but also by being caught in this invisible, cosmic whirlpool created by its siblings. What does it mean for reality when empty space is no longer empty, but a dynamic, flowing entity that guides the dance of suns? Even in the heart of chaos, mathematics finds its voice. While the overall dance of this 14-star system is one of breathtaking complexity, astronomers have isolated pockets of perfect, almost musical harmony. They have found pairs and even triplets of stars whose orbital periods lock into neat, simple integer ratios like 2 and 1 or 3 to 2. This is a phenomenon known as orbital resonance, a gravitational synchronization that creates a stable, repeating pattern against the backdrop of relentless turmoil. It is as if, in the middle of a roaring hurricane, you found a small, quiet room where a perfect, ticking metronome kept flawless time. These resonant orbits are a profound puzzle. In our own solar system, we see this with moons and planets, but those are gentle tugs over billions of years in a relatively quiet neighborhood. Here, in this gravitational mosh pit, such delicate arrangements should be shattered almost instantly by the constant gravitational nudges from a dozen other suns. The fact that they not only exist but persist means they are being actively maintained. Every time a passing star tries to disrupt this harmonic balance, the resonant pull between the locked stars acts as a corrective force, a gravitational feedback loop that gently pushes their orbits back into their perfect rhythm. This is a self-correcting celestial clockwork, a stability that emerges from the chaos itself. How can such fragile order survive in a system so dedicated to upheaval? And what does it reveal about the hidden architecture of gravitational systems we have yet to understand? The perfect mathematical harmony we find in some orbits hints at an invisible hand at work, but what if that hand is far stranger than we ever guessed? The sheer stability of certain resonant pairs surviving in a gravitational hurricane demands an explanation that current physics struggles to provide. This has led to one of the most tantalizing and revolutionary ideas in modern astronomy, the dark matter influence hypothesis. The math is clear. The collective gravity of the 14 visible stars is not enough to account for the precise, reinforced stability we observe in these pockets of order. There is a missing ingredient, a kind of gravitational glue that helps lock these resonant orbits in place against the constant turmoil. The leading candidate is a localized, dense clump of dark matter. Imagine a vast, invisible sphere of this mysterious substance, a shadowy halo enveloping the entire star system. We cannot see it or touch it, but its gravity would be a profound, steadying force. It would act as a cosmic anchor, its gentle, all-pervasive pull providing a stable background against which the delicate dance of resonance can persist. This is not the diffuse dark matter we believe is spread throughout galaxies. This would be a concentrated knot of it, a dark matter subhalo specifically bound to this stellar family. If proven true, this would be a monumental discovery. It would be our first direct look at how dark matter behaves on a small, tangible scale, offering clues to its true nature that particle physicists have sought for decades. Finding such a clump here, in this most chaotic of nurseries, would forever change our understanding of both the cosmos's largest structures and its most elusive particles. What other invisible architectures are holding the universe together, waiting to be revealed by the light of 14 dancing suns? The silence of this chaotic star system has been broken by a signal. Radio telescopes have picked up a whisper cutting through the interstellar noise, a narrow-band transmission so precise it seems almost engineered. Unlike the broad, messy static of stellar flares or the metronomic ticking of a pulsar, this signal is a pure, sharp tone, a single note held on the cosmic piano. And it repeats, but not with any rhythm we can predict. It returns at irregular intervals, sometimes after days of silence, sometimes in a rapid burst of pulses, a pattern that feels deliberate, almost conversational. The discovery ignited an immediate firestorm within the scientific community. On one side are those who argue we are witnessing a new, unknown type of natural pulsar. They suggest a highly magnetized neutron star, one that is precessing or wobbling on its axis like a spinning top. As this wobble shifts the beam of its radio emission, it might only sweep past Earth at these strange, irregular moments, creating the illusion of a patterned signal. It is a compelling natural explanation, but the signal's purity challenges it. A natural cosmic lighthouse usually has some drift, some distortion in its beam, but this tone is unnervingly clean. This leads to the other, far more provocative possibility that we are not listening to a star at all, but to a machine, a technosignature. The narrow-band nature is exactly what our own engineers would design for interstellar communication, as it focuses energy efficiently over immense distances, a laser beam in a sea of flashlights. The irregular repetition could be a form of data packaging, or perhaps a beacon meant to be noticed for its very strangeness, a cosmic hand raised in the dark. Imagine an intelligence born into a sky with 14 suns, a civilization that mastered survival in an environment of perpetual chaos. Their very perception of time and patterns would be alien to us. What kind of message would they send, and what would it say about a life form that calls such a stellar storm its home? A strange and persistent heat clings to this family of 14 suns. When astronomers measured the system's total energy output, they found a significant discrepancy, a surplus of infrared radiation that the stars themselves simply cannot produce. This is not the fierce heat of stellar fusion, but a softer, more diffuse warmth, the kind radiated by vast structures that have been gently warmed by starlight. The source of this unexplained infrared glow is one of the system's most compelling material mysteries. It points to something massive and unseen occupying the space between the stars. One of the most plausible explanations is a colossal debris field, the shattered remains of a planetary system that never was. In the system's violent youth, the gravitational chaos likely prevented planets from coalescing peacefully. Instead, countless planetesimals, the building blocks of worlds, would have collided and ground each other into dust. This would create a sprawling cloud of fine, warm particles that absorbs starlight and re-radiates it as this pervasive infrared glow. It is the thermal signature of cosmic wreckage, a graveyard of potential worlds. Yet, the sheer scale and potential structure of this warm material leads to a far more speculative and thrilling idea. Could we be seeing the waste heat from a Type II civilization? This is a hypothetical society that has harnessed the total energy output of its star, not with a single solid shell, but with a vast, orbiting swarm of energy-collecting platforms known as a Dyson swarm. Such a megastructure would capture a significant fraction of the starlight, using it for incomprehensible purposes, and the inefficiencies of any energy conversion would result in the release of waste heat, which we would detect as this exact kind of infrared excess. Imagine a civilization so advanced that its signature is not a radio message, but the thermal footprint of its immense star-encircling technology. While natural explanations like warm dust are far more likely, the mere possibility forces us to look at this chaotic stellar family in a completely new light. Is this infrared glow the signature of a universe being actively shaped, or simply the warm dust of a construction project that failed before it even began? Some stars in this 14-sun family are moving backwards. Amidst the chaotic swirl, astronomers have identified stars with retrograde orbits, tracing paths that defy the overall direction of the dance. Imagine a single ice skater suddenly reversing their spin in the middle of a perfectly synchronized routine, moving against the flow of every other dancer. This is not a minor quirk, it is a fundamental violation of how star systems are born. When a system forms from a single, collapsing cloud of gas and dust, everything spins in the same direction, a legacy of the original cloud's angular momentum. A retrograde orbit shatters this simple story. It is an orbit that has been flipped, a celestial U-turn of epic proportions. Such a configuration is astronomically difficult to achieve through normal formation processes. The presence of these backwards moving stars is a smoking gun pointing to a violent and dramatic history. The most likely explanation is a capture event. Billions of years ago, this system may have had a close gravitational encounter with another, smaller star system or a lone rogue star drifting through the interstellar void. In the ensuing gravitational tug-of-war, a star from the passing group could have been ripped away and captured, but at a steep angle or even in the opposite direction, forever branding it as an outsider. Another possibility is even more chaotic, a past interaction so violent within the system itself that it literally flipped a star's orbital plane. A close gravitational slingshot around multiple massive bodies could have acted like a cosmic paddle, striking a star and sending it spinning the wrong way. These backwards orbits are more than just orbital oddities. They are permanent records of ancient trespass and turmoil, a reminder that this family of suns was not always as we see it today. What other captured strangers, forever marked by their reverse motion, are hiding within this stellar crowd? A cosmic vampire lurks within this family of 14 suns. Here, a smaller, dense star, often a white dwarf, orbits perilously close to a bloated, cooler giant. In a normal binary system, the vampire's powerful gravity would slowly and steadily strip the outer atmosphere from its larger companion. The stolen gas spirals down, forming a brilliant, hot disk of superheated plasma around the predator star before crashing onto its surface. But this is no normal system. The delicate, predatory dance is constantly interrupted by the gravitational jostling of 12 other suns. A third star might swing by on its chaotic path, its gravity giving the victim star a sudden, violent shake. This can drastically accelerate the feeding process, forcing huge, gushing streams of plasma from the giant star directly into the vampire's grasp. The result is not a steady trickle, but a catastrophic surge of stolen material. The accretion disk, normally a stable, glowing whirlpool, becomes overloaded and unstable. It can flare with incredible brilliance or even fracture under the strain, sending jets of matter screaming out into space. In the most extreme cases, the disruption can trigger a nova, a titanic thermonuclear explosion on the vampire star's surface. This is not a star destroying itself, but a star being forced to digest a colossal meal all at once, leading to a runaway explosion that can briefly outshine all its siblings combined. Yet the chaos can also have the opposite effect. Just as one passing star can enhance the feast, another can yank the vampire away at a critical moment. The stream of stolen gas is severed, the accretion disk starves and fades, and the predator is left hungry, its violent outburst cut short by a gravitational intervention it never saw coming. How many of these stellar feeding frenzies are happening at once? Their rhythms dictated not by their own intimate dance, but by the chaotic sway of an entire celestial family. The chaotic dance of 14 suns may be anchored by an invisible heart, At the very center of this stellar family, astronomers have found gravitational clues pointing to a monstrous presence, a black hole of immense proportions. This is not the stellar mass black hole left by a single supernova, but something far larger, potentially an intermediate mass black hole with the weight of thousands of suns crushed into a single point. Its existence is not revealed by a glowing disk or a jet of radiation, but by the precise motions of the stars themselves. Their wild, unpredictable orbits all seem to pivot around this one central, empty point in space. It acts as a gravitational keystone, a silent anchor whose immense pull provides a focal point for the chaos, preventing the entire system from flying apart. The stars are not just dancing with each other, they are all whirling around a common, dark center of gravity. This could be the secret to the system's surprising longevity. For all its apparent turmoil, the system has endured for billions of years. A central black hole provides the necessary deep gravitational well to keep even the fastest, most erratic stars on a cosmic leash, ensuring that their wild journeys always curve back toward the center. Without this dark anchor, the constant gravitational slingshots and close encounters would have likely scattered the stars to the interstellar winds long ago. What does it mean that the most stable thing in this storm of suns is an object born from ultimate destruction, a silent guardian born from a void? One star in this chaotic family blinks with a strange and perfect rhythm. Amidst the unpredictable flickering of the entire system, a single sun undergoes a deep, periodic dimming that has astronomers utterly captivated. Its light drops by a significant percentage at regular intervals, a pattern so precise you could set a clock by it. Yet this clock is telling a time that makes no sense. The period of this dimming does not match the orbital period of any known star or planet in the system. It is a rhythm without a visible partner, a heartbeat from an unseen body. This points to something vast passing in front of the star, something large enough to block a substantial portion of its light on an orbit that is completely its own. The immediate, thrilling suspicion is a megastructure, an artificial object of staggering scale built by an advanced intelligence. Imagine a vast, geometric array of solar collectors or habitats, a swarm of platforms orbiting in a tight formation, their synchronized transit creating this profound, regular shadow. While this is a captivating thought, nature often has its own, equally bizarre explanations. The leading natural candidate is a colossal swarm of comets, millions or even billions of them, all traveling together in a single, incredibly dense cloud. This is not a loose collection of icy bodies, but a tightly packed river of frozen material. The gravity of 14 stars could certainly sculpt such a swarm, herding these comets into a stable, shared orbit that is completely divorced from the chaotic dance of the stars themselves. The complex gravitational forces might act like a cosmic shepherd, keeping the cloud coherent as it makes its immense journey around the system. Every time this river of ice crosses our line of sight to its star, it would cast a collective shadow, creating the precise, deep dimming we observe. The sheer number of comets required is mind-boggling, an entire Oort cloud condensed into a single, orchestrated train. What could have caused such an immense collection of primordial material to clump together? And what does its clockwork orbit reveal about the hidden, ordering hand within this apparent chaos? A star in this system is a cosmic zombie, a stellar body that should be dead but still shines. Astronomers have identified one member of the 14 Sun family that bears all the scars of a supernova explosion, the most violent death a star can undergo, yet it persists. Its outer layers are missing, stripped away to reveal a bizarre, intensely hot core that pulses with a frantic, unstable energy. This remnant should not exist because a full supernova should have completely annihilated the star or collapsed it into a neutron star or black hole. Its continued, active life is a profound mystery that challenges our understanding of stellar death. The leading theory is that this star experienced a partial supernova, a failed or incomplete detonation. In this scenario, the star's core began the process of collapsing and triggering a supernova, but the explosion was not powerful enough to completely blow the star apart. It was a stellar stroke, a catastrophic event that blew off the star's outer envelope but left the central engine still sputtering and alive. The result is a freak of nature, an exposed stellar core that continues to fuse elements erratically, its pulsations driven by the traumatic instability of its near-death experience. Another possibility involves the system's chaotic nature directly. The zombie star might have been on the verge of exploding when a close encounter with a companion altered its fate. In a desperate act of stellar theft, it could have siphoned a colossal amount of mass from its neighbor at the last possible second. This sudden influx of fresh fuel could have reignited fusion processes in its core, effectively restarting the star and averting a full collapse, but leaving it permanently disfigured and unstable. This bizarre, pulsating object is neither a true living star nor a clean corpse. It is a celestial anomaly that forces us to rewrite the textbook on how stars die, especially when they live in a crowded, violent neighborhood where the rules are constantly being broken. The magnetic fields here are not confined to individual stars but weave a web of pure force across the entire system. These are not simple, orderly fields like the ones surrounding our own Earth. They are monstrously powerful, tangled knots of magnetic energy that physically link one star to another, creating invisible bridges across millions of kilometers of empty space. This is the most complex and powerful magnetosphere ever conceived, a system-wide network of force that channels matter and energy like a cosmic power grid. When a stellar flare erupts on one star, the explosion does not just dissipate into the void. The magnetic highways grab hold of the ejected particles, funneling them at near light speed along these pre-established paths. A torrent of superheated plasma, a river of fire, can be shunted directly from one star to another, slamming into its atmosphere and triggering secondary eruptions far from the original source. This creates a chain reaction of violence, a domino effect of stellar fury that can set the entire celestial family ablaze with activity simultaneously. The energy involved is almost beyond calculation. These fields are so intense they can strip atoms apart, tearing electrons from their nuclei and accelerating the resulting particles to velocities that defy belief. The entire system is encased in a shimmering, invisible cage of unimaginable force, a dynamic architecture that turns 14 individual stars into a single, interconnected electrochemical engine. What does it mean for the very fabric of reality when stars are not just neighbors, but are literally wired together by the universe's most fundamental forces? Within this ancient stellar family, astronomers have found suns that defy the natural order of time, stars that shine with the vibrant energy of youth. These stellar outliers spin with a frantic, youthful speed and possess a chemical signature that should have vanished eons ago, an unusually high abundance of the element lithium. In a normal, aging star, lithium is one of the first elements to be consumed and destroyed in the nuclear fires of its core. Its presence in such quantities is like finding a fully grown adult with the fresh, unweathered skin of a newborn, a cosmic paradox that points to a profound rejuvenation. These stars have not simply aged well, they have had their internal clocks reset by violent intervention. The most likely culprit is a stellar merger, a catastrophic collision between two older stars. When two suns crash together, their combined material is violently stirred, like a giant blender churning the contents of both. This process brings fresh hydrogen from their outer layers down into the hot core, reigniting fusion at a ferocious rate. The star is literally reborn from the wreckage, emerging hotter, brighter, and spinning rapidly from the angular momentum of the collision. It is a phoenix rising from a double funeral. Another path to this renewed youth is a more gentle but equally transformative mass transfer. Imagine an aging star in a close binary pair, slowly having its outer envelope of hydrogen siphoned away by a companion. This stripping action can remove the star's aged, lithium-depleted outer layers, revealing the pristine, lithium-rich material beneath. It is a cosmic facelift, peeling away the old surface to expose a younger one. The influx of fresh hydrogen can also reinvigorate the star's core, causing it to burn brighter and spin faster as it contracts. These are not young stars, they are imposters, ancient celestial bodies masquerading as newborns thanks to the system's relentless chaos. What does it mean for our understanding of stellar life cycles when a star's age can be so dramatically rewritten by the violence of its family? The silent thunder of 14 dancing suns fills the cosmos with a vibration no human ear can hear. Every close encounter, every chaotic swing, and every sudden acceleration in this system sends ripples through the very fabric of space-time. These are gravitational waves, not the sharp chirp from two black holes merging, but a low, persistent hum that has been resonating for billions of years. The collective motion of all 14 massive stars generates a continuous background of these waves, a kind of cosmic static that permeates the space around them. It is as if the entire system is a giant bell that has been struck, and it has never stopped ringing. This hum is too low in frequency for our current observatories like LIGO to detect. Its wavelength is so long it could span the entire solar system, a deep bass note in the symphony of the universe, but the future holds the key to listening in. Upcoming missions like the Laser Interferometer Space Antenna, or LISA, are being designed specifically to tune into this low-frequency gravitational wave background. LISA will consist of 3 spacecraft flying in a giant triangle millions of kilometers apart, using lasers to measure the infinitesimal stretching and squeezing of space as these waves pass by. When it begins its observations, the Quattuordecuple system will be a prime target, a celestial orchestra playing a song we have only been able to imagine. By studying this specific hum, scientists will gain a completely new way to understand the system's dynamics. They will be able to hear the orbital periods of the stars, sense the close passes, and even detect the presence of unseen compact objects like black holes or neutron stars by the subtle changes they impose on the gravitational soundtrack. This is not just adding another sense to our observation. It is listening to the universe's most fundamental music, a direct broadcast from a dance of giants that has been ongoing since the dawn of time. What secrets will we decipher when we can finally hear the rhythm of this chaotic stellar family? This star suffers from a profound identity crisis, its very nature shifting before our eyes. Astronomers have watched in disbelief as one member of the 14 Sun family appears to change its fundamental type, oscillating wildly between a hot, blue, youthful star and a bloated, cool, red giant. Its spectrum, the unique fingerprint of its temperature and composition, is a chameleon refusing to stay constant. One year it screams the intense, energetic lines of a blue star burning fiercely, and a few years later it whispers the cooler, more complex signature of a red giant. This is not a normal stellar evolution which unfolds over millions of years. This is a transformation happening on a human timescale, a stellar metamorphosis driven by the system's relentless violence. The cause is a desperate struggle over stellar flesh, a rapid and chaotic cycle of loss and gain. The star is caught in a gravitational crossfire, likely locked in a tight, punishing orbit with one or more companions. During one phase of its chaotic path, it falls victim to a cosmic vampire, having its outer atmosphere violently stripped away. This mass loss exposes its hotter, denser interior, causing it to appear hotter and bluer, as if it has shed its skin to reveal a younger self. But the story does not end there. The system's dynamics are so complex that the tables can quickly turn. A gravitational nudge from a passing third star can alter the balance of power, or the victim star might swing close to a different, gas-rich giant. Suddenly, the star that was losing mass becomes the recipient, accreting a colossal influx of fresh, cool hydrogen onto its surface. This new blanket of material smothers its hot core, causing it to swell and cool, transforming it back into the appearance of a red giant. It is a star being constantly remade by its environment, its identity dictated by whether it is the thief or the victim in a perpetual celestial robbery. What does it mean for a star to have no true self, to be a temporary collection of matter, forever reshaped by the gravitational winds of its chaotic family? This entire chaotic family of 14 suns might be a group of interstellar immigrants. Astronomers have mapped the precise motion of the system as it travels through our galaxy, and the data tells a startling story. The system is moving too fast and at too sharp an angle relative to the galactic plane to have been born here. Its trajectory is an anomaly, a path that points to an origin far outside the Milky Way. The most compelling explanation is that this Quattuordecuple system did not form in our cosmic neighborhood. Billions of years ago, it was likely the central jewel of a small, orbiting dwarf galaxy. During a close gravitational encounter with the nascent Milky Way, that smaller galaxy was torn apart, its stars scattered and absorbed. But this dense, complex family of stars was so tightly bound by its own internal gravity that it survived the disruption intact. It was plucked from its original home and captured by our galaxy, a complete stellar ecosystem adopted into a new cosmic city. This violent history of galactic theft explains so many of its unique properties. Its ancient, recycled stars and the presence of stellar corpses make perfect sense if it is billions of years older than we first assumed. The chaotic orbits that seem so unstable may in fact be the system's normal state, a dynamic balance forged in a different galactic environment with different rules. This system is not a bizarre outlier of our own galaxy's formation. It is a celestial fossil, a preserved relic from a time when galaxies collided and merged, building the universe we see today. Its very presence is a living record of a past cataclysm, a ghost of a long-dead galaxy still dancing in our sky. Deep within the hearts of the system's dead stars, a strange transformation may be underway. Among the white dwarfs, the Earth-sized embers of former suns, astronomers have detected a peculiar pattern in their cooling. These stellar corpses are fading faster than our models predict, and their faint pulses, the slow heartbeat of their remaining heat, have a strange, resonant quality. This data has sparked a controversial but dazzling hypothesis, the idea that these white dwarfs are not just balls of dense carbon and oxygen, but are in fact turning into cosmic diamonds. The conditions are perfect for such an alchemy. A white dwarf is one of the densest objects in the universe, no longer powered by fusion. Its incredible mass is supported only by a quantum mechanical effect, electron degeneracy pressure. In the core, the pressure is so immense that atoms are smashed together in a lattice, their electrons forming a degenerate sea. For a carbon-rich white dwarf, this pressure can reach a threshold where the carbon itself crystallizes, forming a structure akin to a diamond but on a planetary scale. Imagine a single, perfect crystal with the mass of a star and the size of a planet, a jewel forged in the heart of a dead sun. The unusual cooling curves support this as the process of crystallization releases latent heat, changing how the star fades over time. The specific pulsation patterns are the true giveaway, ringing with a pure tone that suggests a solid, resonant interior rather than a liquid one. This is not a serene process, however. The gravitational chaos of the 14-star system likely accelerated it, the constant tidal squeezing from nearby stars acting like a trillion anvil presses, forcing the crystallization to occur faster and more completely than in an isolated white dwarf. Could these stellar graveyards be the universe's most magnificent treasure chests, glittering with diamonds born from celestial violence? Each star in this chaotic family breathes out its own atmosphere, creating a hurricane of stellar winds that scream into the void. These are not gentle breezes, but supersonic rivers of charged particles, and with 14 stars all blowing at once, their collision is a constant, violent storm. The result is a single colossal structure that encases the entire system, a bizarre and ever-changing heliosphere. This is the system's final frontier, a bubble of hot plasma millions of times larger than our own solar system's protective bubble, a shield forged from pure chaos. Within this bubble, the winds do not simply mix, they engage in a perpetual war. A fast, thin wind from a hot blue star slams into the slow, dense outflow from a cool red giant. The shockwaves from these collisions ripple across the entire structure, creating regions of intense, turbulent pressure and vast, empty voids. The entire bubble pulses and morphs, its shape shifting with the erratic orbits of the stars inside, a breathing entity of pure energy. For any hypothetical planet huddled within this system, this unstable shield would be the difference between life and oblivion. There would be no predictable cycle of protection. For centuries, the overlapping winds might create a stable, protective barrier, deflecting the deadly cosmic radiation that pours in from the wider galaxy. Then, a shift in the stellar dance could tear a temporary hole in this plasma shield. A planet might find itself suddenly exposed, its surface bathed in a flood of high-energy particles that would scour away any fragile atmosphere. The sky would not just be a spectacle of multiple suns, but a constant, invisible gamble with radiation, a lottery of survival dictated by the squalls of a stellar hurricane. What kind of life could evolve under a sky where the very air you breathe is periodically sterilized by forces entirely beyond your world's control? Light from a long dead star still whispers across this system. Astronomers have captured a ghostly phenomenon known as a light echo, a delayed reflection from an explosion that occurred centuries or even millennia ago. When a star in this family went supernova, the initial flash of light raced outwards in all directions at, of course, the speed of light. But some of that light did not travel directly to us. Instead, it struck vast, distant clouds of dust drifting between the stars, like a flashlight beam hitting a cosmic curtain. This light was absorbed by the dust particles and then re-radiated back into space, creating a secondary, fainter pulse that is only now reaching our telescopes, an echo of a cataclysm we missed. This echo is far more than a simple flash in the dark. By analyzing its spectrum, scientists can dissect the light as if they were there at the moment of detonation. They can determine the exact composition of the star that died, measuring the specific mix of iron, silicon, and oxygen that was forged in the final, violent instant. They can even measure the speed and shape of the explosion's shockwave, revealing whether it was a symmetrical blast or a lopsided, chaotic rupture. This single echo provides a forensic report on a death that happened before telescopes ever existed. It confirms that the system has endured not just one, but multiple supernovae, each one a potential extinction-level event for any nearby worlds. The very dust that now obscures our view also acts as a cosmic recording device, preserving the screams of dying stars for us to hear long after they have fallen silent. What other forgotten explosions are still echoing through this chaotic family, waiting for their light to finally reach us? A planet in this system could trace a perfect figure 8 in its sky. Orbital simulations reveal that amidst the chaos, a strange and beautiful stability can emerge, a path where a world loops continuously around two separate stars. This is not a theory confined to supercomputers. It is a gravitational possibility that becomes real only in an environment as extreme as this one. For a figure 8 orbit to exist, the two central stars must orbit each other in a very specific, tight dance, their gravitational pull creating a balanced corridor through space. The planet moves as if it is sliding along an invisible rail, first falling towards one star, swinging around it, then being passed through the central balance point to fall towards the second. It is a cosmic slalom, a perpetual motion machine powered by gravity itself. The journey would defy all earthly intuition. The planet would experience a continuous, rhythmic shift in its heavens. As it approaches the first star, that sun would swell to a brilliant, terrifying disk, dominating the sky with its heat and light. Then, as the world whips around it and is flung towards the central point, the two stars would appear as twin suns of equal size, locked in a celestial standoff. The moment it crosses the center, the first star would rapidly diminish, and the second would grow to take its place as the primary source of light and warmth. There are no seasons as we know them, only a cyclical, predictable lurch between two different stellar environments. One half of the orbit might bring a scorching summer, while the other delivers a deep, frigid winter, with the transition between them happening in a matter of weeks. How could life gain a foothold on a world whose very climate is a pendulum, swinging between two different kinds of stellar fury? The 14 stars simply do not weigh enough. When astronomers calculated the total mass needed to keep this chaotic family gravitationally bound, the numbers did not add up. The combined weight of every visible sun, every white dwarf, and every suspected neutron star falls dramatically short of the gravitational pull actually governing their orbits. It is as if you weighed every person in a crowded room, but the floor was sagging as if under the weight of an invisible elephant. This is the missing mass problem, a profound gap in our understanding of what this system is truly made of. The gravity we can measure points to a colossal amount of unseen material, a hidden skeleton providing the bulk of the system's gravitational muscle. So what is this phantom mass? One possibility is a vast population of dark matter, the mysterious substance that makes up most of the universe's mass. Perhaps this system is enveloped in an incredibly dense, localized cloud of it, a dark matter halo whose gravity is the true anchor holding everything together. Another, more tangible explanation is a staggering number of rogue planets. Billions of worlds torn from their stars by gravitational encounters could now be drifting through the system as a vast, invisible fleet of dark, frozen bodies. Their collective mass, while individually small, could add up to a significant fraction of the missing weight. The most dramatic solution, however, involves a graveyard of black holes. The system's violent history of supernova and stellar collisions could have left behind dozens, even hundreds of stellar mass black holes. These perfect black spheres would be utterly invisible against the void, their presence betrayed only by the subtle way they tug on the light of their living siblings. This single system could be a nest of these dark predators, their collective gravity weaving the unseen web that cages the 14 dancing suns. What other invisible giants are we failing to see, and how many ghosts does it take to hold a storm of stars together? Even across vast distances, these stars beat as one. A set of suns within the system are pulsating in a perfect, shared rhythm, their brightness swelling and fading in flawless synchrony. They are not simply following the same tempo, they are locked in phase, like a chorus of cosmic heartbeats all thumping at the exact same moment. This coordination is not a coincidence, it is a phenomenon known as resonant pulsation. Each star has a natural, internal vibration, a rhythm set by the churning of its own plasma. In the crowded gravitational environment of this family, these vibrations are not isolated. The subtle, persistent tug of gravity between the stars acts as a conductor, synchronizing their internal oscillations until they all fall into step. It is a form of gravitational coupling, an invisible force linking their very hearts across light years of space. This creates a natural symphony, a low-frequency music played on instruments the size of suns. The energy transfer is subtle, a gentle push and pull that happens over centuries, but the effect is profound. When one star contracts, its tiny gravitational shift encourages its partner to do the same, and the pulse travels through the group. To witness this from a hypothetical world within the system would be to see a sky where multiple suns gently breathe together, brightening and dimming in a slow, majestic harmony. This celestial harmony reveals a layer of order beneath the chaos, a gentle conversation happening beneath the screams of gravitational violence. What other subtle, interconnected rhythms are pulsing through the cosmos, waiting for us to learn how to listen? This stellar chaos may solve one of the universe's greatest silences. The sheer violence and instability of these 14 star systems could be the very reason we have found no other intelligent life. This idea connects directly to the Fermi paradox, the puzzling contradiction between the high probability of alien civilizations and our complete lack of evidence for them. The Great Filter hypothesis proposes that at some point between the emergence of life and the development of a spacefaring civilization, a nearly insurmountable barrier arises. For worlds trapped in a Quattuordecuple system, that filter is not a single event, but a constant, brutal condition of existence. Imagine a planet where the very fundamentals for life are perpetually under assault. Complex molecules, the building blocks of biology, would be routinely shredded by intense stellar radiation during a close stellar pass. A stable climate, which on Earth allowed life to evolve over billions of years, is an impossible dream here. The planet might be flash-frozen in the cold of a wide orbit, only to be scorched and stripped of its atmosphere when it swings close to a star. Just as a civilization begins to develop technology, a nearby supernova or a gravitational disruption could sterilize the entire world, resetting the evolutionary clock to zero. These systems are not just rare cosmic oddities, they could be galactic dead zones. If a significant fraction of the galaxy's stars exist in such chaotic families, then a vast number of potential cradles for life are rendered sterile. The silence we hear when we listen to the cosmos might not be a sign that we are alone, but a terrible whisper telling us that we are among the lucky few who won the cosmic lottery, born into a quiet, stable neighborhood where such filters do not exist. What does our own peaceful solar system say about our place in a universe seemingly designed for chaos? The most powerful natural particle accelerators in the universe might not be found in the hearts of galaxies, but right here in this chaotic family of 14 suns. For decades, astronomers have been puzzled by ultra-high energy cosmic rays, subatomic bullets that scream across the cosmos with energies millions of times greater than anything produced in our largest human-built colliders. These particles are so rare and so powerful that their source has been one of astrophysics' greatest mysteries. Now, by tracing their paths backwards across the sky, scientists have found a startling number of them pointing directly back to Quattuordecuple star systems. This is a profound revelation. It means these stellar families are not just beautiful chaos, they are cosmic engines capable of ferocious violence on a subatomic scale. Imagine the gravitational turmoil acting like a trillion slingshots working in concert. A single charged particle, a proton or an atomic nucleus, gets caught in the shifting gravitational and magnetic fields of 14 different stars. It is whipped around one star, gaining a burst of speed, then flung across the system only to be captured by the magnetic field of another. With each close pass, it gains more and more energy, faster and faster, until it is finally ejected from the system like a bullet from a rifle, traveling at a velocity infinitesimally close to the speed of light. This process is far more efficient and powerful than anything we see near a supernova remnant or the jet of a distant black hole, because here, the acceleration is not happening in one place, but across the entire churning volume of the system. These stellar families are, in effect, the universe's ultimate particle accelerators, far grander and more potent than anything we could ever hope to build. What other fundamental secrets of physics are being forged in these chaotic crucibles, and what happens when such a high-energy particle finally strikes another world? A cosmic mirror reflects two stars that are perfect twins. They formed from the same cloud of gas, possess the same mass, and share the exact chemical composition. They are siblings in every measurable way, born under the same violent sky. Yet one shines as a stable, middle-aged star, steadily fusing hydrogen in its core, while its twin is a white dwarf, the dense, fading ember of a star that has already lived and died. This is a paradox that should not exist, a fundamental challenge to the very timeline of stellar life. How can two stars with identical starting points reach such dramatically different ends? The answer lies in the system's relentless chaos. The white dwarf did not die of old age, it was murdered by its family. In a system with 14 gravitational players, close encounters are a constant threat. Billions of years ago, this star likely had a series of devastatingly close passes with one or more of its massive siblings. These encounters would have stripped away its outer layers at a ferocious rate, like a cosmic peel being violently torn off. This process robbed the star of its future. It lost so much mass so quickly that its core could no longer sustain the nuclear fusion that defines a main sequence star. Its internal engine was effectively shut down prematurely, leaving it to collapse into a white dwarf far ahead of its natural schedule. Meanwhile, its identical twin, perhaps orbiting just a little further from the chaos, continued its normal, peaceful evolution. We are not looking at a difference in age, but a difference in experience. One star lived a quiet life, while the other endured a traumatic assault that forced it into an early grave. This mirror pair is a stark lesson that in a chaotic universe, your fate is not written solely in your mass, but in the company you keep and the gravitational storms you are forced to survive. What other stellar lives have been cut short by the violence of this family? And how many more of these impossible twins are waiting to be found? Some of these stars are cloaked in phantom atmospheres that appear from nothing and vanish just as quickly. Astronomers have observed thin, high-altitude layers of gas suddenly materializing around a star, lingering for a few months and then dissipating back into the void. This is not the star's own atmosphere, which is stable and immense, but a temporary shroud, a celestial veil that forms and fades on a human timescale. The discovery of these transient layers adds another layer of mystery to the system's chaotic dynamics. They point to a constant, invisible exchange of matter happening right before our eyes. The most likely explanation is a process of stellar ablation, a form of cosmic sandblasting. When two stars make a perilously close pass, the gravitational tides between them become overwhelming. The smaller or more vulnerable star does not just feel a pull, it has its outermost layers of gas literally sandblasted away by the sheer force. This stripped material does not instantly fall onto the other star. Instead, it can be flung into a wide orbit, forming a vast, tenuous cloud that slowly spirals inward. As this cloud of ablated gas drifts across the face of the other star, our telescopes detect it as a temporary, high-altitude atmosphere, a ghostly imprint of a recent violent encounter. Another possibility involves the system's bizarre chemistry. The constant gravitational stress might be churning up material from the deep interiors of these stars, bringing exotic, heavy elements to the surface that normally remain hidden. In the extreme cold of the high stellar atmosphere, these elements could briefly condense like metal vapor cooling to form a mist, creating a reflective layer that vanishes when the star's own heat or a gravitational jolt vaporizes it. Imagine watching a star slowly wrap itself in a shimmering cloak of metallic fog, only to have it dissolve without a trace half a year later. These phantom atmospheres are more than just a curiosity. They are a direct recording of the intimate and destructive dances happening between the stars, a visible breath of the gravitational tides that constantly reshape this family. What other fleeting phenomena are we missing in the brief moments between our observations? The extreme curvature of space-time here offers a testbed for theories once confined to science fiction. Warp drive concepts, which propose bending the fabric of space to achieve travel faster than light, are no longer just mathematical curiosities. The 14-star system acts as a natural laboratory where these ideas can be stress-tested against reality. The chaotic gravitational fields create a constantly shifting landscape of warped space, a pre-existing condition that allows physicists to observe how space-time behaves under stress. They can measure how light and energy propagate through these twisted regions, searching for anomalies that our current models of physics cannot explain. Some of the most advanced theoretical models predict specific energy signatures that would be the telltale fingerprint of a stable warp bubble. These are not the messy explosions of supernova, but subtle, organized distortions in the fabric of reality itself. One key signature is a specific pattern of negative energy density. In simple terms, this would be a region of space that somehow has less than zero energy, a bizarre concept that is mathematically required to keep a warp bubble open and stable. Another signature is a unique form of gravitational lensing, where the distorted space around a potential warp region would bend light in a way that is distinct from the lensing caused by a simple mass like a black hole. It would create multiple shimmering images that shift in a precise, non-chaotic pattern, a clear sign of an engineered curvature rather than a natural one. While we are not suggesting aliens are building warp drives here, the system's natural extremes allow us to look for the physical proof that such a thing is even possible. It lets us ask if the universe's own rules permit a shortcut through the stars. What would it mean if we found that signature, a whisper of physics that could one day unlock the galaxy? A faint but unmistakable isotopic signature lingers in the light of this system, pointing to an explosion beyond a supernova. Deep within the stellar graveyard, astronomers have found evidence for a quark nova, a theoretical event so violent it represents the death of a death. This begins with a neutron star, the collapsed core left after a supernova, an object so dense its very atoms have been crushed. Under the immense gravitational pressure, electrons are forced into protons, creating a sphere of pure neutrons. In a stable neutron star, this is the end of the line. But in this chaotic system, where gravitational tides from passing stars can squeeze and destabilize these corpses, the collapse may have gone one step further. The pressure might have become so overwhelming that the neutrons themselves shattered. Think of a neutron star as a vast, dense crystal. A quark nova is the moment that crystal is struck with a cosmic hammer, shattering it into its most fundamental components, free quarks. The energy release from this sudden, catastrophic deconstruction would dwarf the original supernova, a second, far more violent death scream. The evidence is written in the starlight of the system's living members. Their atmospheres are polluted with a specific mix of rare, heavy isotopes, particularly forms of platinum and gold, that can only be forged in the unique, unimaginable conditions of a quark nova. It is the cosmic equivalent of finding the unique chemical residue of a high explosive at a crime scene, confirming a specific type of detonation. The remnant of such an event would not be a neutron star anymore, but a strange star, a hypothetical object made of a soup of free quarks, a state of matter that should not exist stably in our universe. This transforms our understanding of stellar death. We thought a supernova was the final word, but here, in this gravitational pressure cooker, we see it can be merely the first act in a two-part tragedy. What other fundamental laws of matter are being rewritten in the heart of this chaos? The interstellar space within this family of 14 suns is far from empty. It is a dense, soupy fog of gas and dust, the raw material left over from its violent birth. Normally, a star drifting through such a cloud would act like a cosmic vacuum cleaner. Its immense gravity would pull the gas inward, creating a smooth, focused stream of material falling onto its surface in a process known as Bondi-Hoyle accretion. But here, there are not one, but 14 gravitational vacuum cleaners all fighting over the same meal. The result is not an orderly feast, but a chaotic, cosmic food fight where the rules of physics create a frenzy of inefficiency. Each star's gravity tries to pull the surrounding gas into its own orbit, but with so many competing pulls, the interstellar medium is torn in countless directions. A single cloud of hydrogen might begin a slow fall toward one star, only to be yanked away by the stronger gravity of a closer neighbor. Then, a third star might swing by on its chaotic path, its gravity whipping the gas into a new, entirely different trajectory. This creates a turbulent, unpredictable environment where the flow of material is constantly being shredded and redirected. The accretion process becomes wildly inconsistent. A star might experience a sudden, violent gush of infalling material as it plows through a dense pocket of gas, its surface heating up dramatically from the impact. For a brief period, it glows brighter and hotter, feasting on the cosmic bounty. But just as quickly, the flow can be cut off. A passing sibling star can gravitationally steal the incoming stream, or the chaotic tides can simply disperse the gas cloud into a thin, unusable haze. The star is then left starving, its brief banquet over, its light fading back to its normal state. This erratic feeding cycle means the stars are in a constant state of metabolic imbalance, their growth and energy output dictated not by their own stable fusion, but by the unpredictable generosity of their shared and fiercely contested environment. What does this perpetual struggle for cosmic resources do to the long-term evolution of a star, when its very growth is subject to the whims of a gravitational free-for-all? A river of stellar gas flows in a perfect, unbroken circle. This is the Ouroboros stream, a continuous loop of superheated plasma that begins at one star, travels a vast and complex path through the gravitational maze of the entire system, and returns to pour back into the very same star it left. It is a star literally feeding on its own lost atmosphere, a celestial version of the ancient symbol of the snake eating its own tail. The existence of such a stable circuit defies all expectation in a place defined by chaos. For this loop to persist, the gravitational forces must be exquisitely balanced. The gas is not simply drifting, it is channeled along a gravitational trough, a preordained highway in space carved out by the combined pull of all 14 suns. As the stream of gas leaves its home star, it is caught in this invisible groove, forced to follow a path that winds around other stars, using their gravity like slingshots to maintain its momentum and curve it back toward its point of origin. The entire loop acts as a single, coherent entity, a cosmic conveyor belt that has found a perfect, stable resonance within the storm. This creates a bizarre form of stellar recycling. The star is both the source and the sink, constantly losing mass to the stream and then reacquiring it. The gas that completes the journey returns hotter and enriched with different elements picked up from its voyage through the system, subtly changing the star's composition over time. It is a form of cosmic respiration, a star breathing its own essence out into the void only to draw it back in again. How many other such self-sustaining circuits are hidden within this dance? And what does this perfect, closed loop say about the hidden order woven into the universe's most apparent chaos? Deep within the heart of this stellar chaos, the very laws of physics as we know them may be breaking down. The immense gravitational pressures inside the most massive stars, or within the central black hole itself, are so extreme that they create conditions where Einstein's theory of general relativity is no longer the final word. These are realms where the smooth, geometric picture of warped space-time gives way to a frothing, uncertain quantum sea. The gravitational pull is so strong that it operates on the same minute scale as the quantum forces that govern particles, a domain where no theory has yet successfully united them. This is the frontier of quantum gravity, and this chaotic system might be our first real-world laboratory to observe its effects. One potential signature is a subtle, yet fundamental, change in how gravity behaves over the smallest distances. According to some theories, at this quantum level, space-time itself may not be continuous but granular, composed of tiny, discrete units. This pixelation of reality would be far too small to detect on Earth, but under the crushing gravity near a super-dense object, its effects could magnify. It might cause light to scatter in a specific, anomalous way as it passes through these highly curved regions, or it could alter the precise orbital decay of two stars spiraling into each other. Another clue could be found in the behavior of matter at the edge of a black hole's event horizon. General relativity predicts a smooth, one-way membrane, but quantum gravity suggests something far more turbulent, a firewall of intense energy or a fuzzy quantum foam boundary. Matter crossing this threshold might release a unique, high-energy flash or a specific pattern of gravitational waves that our current models cannot explain. Finding such a deviation would be like discovering a single typo in a fundamental law of the universe, a small crack that reveals an entirely new layer of reality beneath. These 14 suns, with their monstrous densities and violent interactions, are pushing matter and energy to their absolute limits, creating the perfect storm to test our most profound ideas. What cosmic secrets are hidden in the heart of a collapsing star, waiting to rewrite our understanding of reality itself? These stellar orbits carry a memory of their violent birth. While their paths appear chaotic today, advanced computer simulations have peeled back the layers of time, revealing a faint but unmistakable ghost in the celestial machinery. The current, dizzying dance of the 14 suns still holds a subtle imprint of the system's original configuration from over 10 billion years ago. It is a fossil record not written in stone but in gravity itself. Uncovering this required letting virtual stars live out their lives inside supercomputers. Researchers began with a simple, elegant starting arrangement, a placid disk of gas and dust, and then let the laws of physics play out over billions of simulated years. The first attempts failed spectacularly, the digital systems either tearing themselves apart or settling into patterns that looked nothing like the real one. The breakthrough came when they introduced a specific initial asymmetry, a slight gravitational lopsidedness in the primordial cloud. When they ran this new simulation, the resulting chaos was a near-perfect match for the tangled orbits we observe today. The key was finding the hidden constants. Amidst the ever-changing orbital paths, certain mathematical relationships remained stubbornly preserved. The angles between the orbital planes of specific star pairs, for instance, or the ratios of their maximum and minimum distances from the system's center, have changed far less than everything else. These are the system's gravitational memories, the few threads of order that have stubbornly persisted through eons of turmoil. Decoding this fossil record is like trying to reconstruct the original shape of a shattered vase by studying only the final, scattered pieces on the floor. The pattern of the fragments holds a clue to the initial impact. For this stellar family, that impact was its own violent formation. The specific wobbles and tilts we see today are direct echoes of the gravitational tug-of-war that first assembled these 14 suns, a signature that has survived countless close calls and near catastrophes. This persistence of memory tells us that even the most chaotic systems are not entirely random. They are bound by their own history, carrying the scars of their origin across billions of years. What other ancient secrets are encrypted in the gravitational code of these 14 dancing suns? Even the smallest tremors in starlight can betray immense secrets. The Gaia spacecraft, an eye in the sky of unmatched precision, has mapped the positions of these 14 suns with an accuracy that borders on the unbelievable. It can detect a wobble in a star's location equivalent to seeing a coin on the surface of the moon from Earth. And in this chaotic family, it has found just that tiny, rhythmic shudders in the paths of several stars that the gravitational pull of their 13 visible siblings cannot explain. These are not the grand, chaotic swings from close encounters, but subtle, persistent tugs, as if invisible threads are gently pulling on these giants. So what could be exerting this faint, precise force? The most hopeful explanation is a hidden population of planets. In the stable gravitational pockets between the stars, entire worlds could be orbiting, their collective gravity creating this minuscule but measurable dance. We could be looking at the signature of solar systems within a solar system, planets that have somehow survived the perpetual storm. A far more exotic possibility involves dark matter. We think this mysterious substance is spread smoothly throughout galaxies, but what if it clumps? A dense knot of dark matter, a miniature shadow galaxy bound to the star system, could be brushing against these stars, its gravity creating the observed wobbles without emitting a single photon of light. But the most mind-bending hypothesis points to a flaw in the cosmos itself. Theoretical physicists speak of cosmic strings, hypothetical defects in the fabric of space-time, relics from the universe's first explosive moments. Think of the universe cooling from a state of perfect symmetry, and in that process developing cracks like flaws forming in a crystal as it solidifies. A cosmic string would be an unimaginably dense, one-dimensional scar in reality, a thread of pure mass thinner than an atom but stretching across light years. Its gravitational pull would be immense, and as it drifts through the Quattuordecuple system, it could gently tug on the stars, creating the precise wobbles that Gaia sees. We would be witnessing the ghostly fingerprint of a crack in creation, a fossil from the first second of the Big Bang, its presence revealed only by the subtle shiver it imposes on 14 dancing suns. What other primordial scars might be woven through the universe, invisible until they pluck at the strings of reality? This entire stellar family is on a journey pulled by a force we cannot see. Astronomers have mapped its trajectory across the galaxy and found something deeply unsettling. The system's proper motion, its path through the cosmos, aligns with the direction of one of the most profound mysteries in modern astronomy, the Great Attractor. This is not a star or a black hole we can observe. The Great Attractor is a gravitational anomaly, a point in intergalactic space with the mass of tens of thousands of galaxies, pulling everything in our corner of the universe toward it. Its true nature is hidden behind the dense plane of our own Milky Way, obscured by countless stars and cosmic dust. We feel its pull but cannot see its face. And now we see one of the most chaotic systems we know, a family of 14 suns, seemingly marching in step toward this cosmic siren. The alignment is too precise to dismiss as mere chance. It suggests the invisible hand shaping the grand flow of galaxies is also reaching down to guide the path of this single, intricate system. Think of it as a leaf caught in a vast river current. The leaf tumbles and spins in its own local eddies, which for the stars is their chaotic gravitational dance. But the overall direction it travels, the path of the river itself, is dictated by the landscape far beyond the leaf's perception. This system's local chaos is real, but its ultimate destination may be written by a force of almost unimaginable scale. What does it mean for our understanding of gravity if the largest structures in the universe can directly influence the motion of something as relatively small as a family of stars? This connection blurs the line between the cosmic and the local, suggesting that the fate of these 14 suns is entwined with the hidden architecture of the entire cosmos. The ultimate fate of this stellar family is a symphony of destruction written in the language of gravity. Supercomputer models, fed with every known detail of the system's mass, velocity, and orbital chaos, project a future of escalating violence over the next few billion years. It begins with a chain reaction of close encounters. As the stars continue their chaotic dance, their paths will inevitably intersect more and more frequently. The first collisions will likely involve the smaller, more numerous red dwarfs. Two such stars, swung together by the gravitational tides of their larger siblings, will not simply bounce apart. They will merge in a titanic flash, creating a new, more massive star that burns hotter and brighter, further destabilizing the delicate gravitational balance of the entire group. This single merger sets off a cascade. The new, heavier star now follows a different, more disruptive path, its increased gravity yanking other stars into new, even more perilous orbits. This pushes other binary pairs once stable over the edge. A pair of suns locked in a tight embrace will have their orbit decay until they spiral into each other, triggering another stellar merger. Each collision sends gravitational shockwaves through the system, tightening the noose for the remaining stars. The supernova will begin shortly after. The most massive stars, the brilliant blue giants, were never destined for long lives. The constant gravitational stress from this escalating pandemonium will hasten their end. One by one, they will exhaust their nuclear fuel and explode in cataclysmic supernova. Each explosion is a double-edged sword for the system. The blast waves will scour the system of any remaining gas and dust, and the violent, asymmetric kick from the detonation will eject some of the newly formed neutron stars at incredible speeds, lost to the galactic void forever. Yet, for every star that is ejected, the system's total mass decreases, but its gravitational heart grows darker and denser. The neutron stars and stellar mass black holes left behind by these supernovae will begin their own grim dance. In the ever-tightening confines of the system, these dead stars will also collide. A collision between two neutron stars is one of the most energetic events in the universe, spraying space with heavy elements like gold and platinum, and likely forming a new black hole. This is the system's end game, a relentless consolidation of mass and gravity. Over billions of years, the chaotic family of 14 will be whittled down through mergers, explosions, and ejections. The final state predicted by the models presents two equally dramatic possibilities. In the first, the consolidation continues unabated. All remaining objects, living stars, white dwarfs, neutron stars, and stellar black holes are drawn into the system's center, drawn by the growing pull of the most massive black holes. They merge and merge again, snowballing into a single, monstrous intermediate mass black hole, a silent and dark sovereign ruling over a graveyard of starlight. The second possibility is a final, explosive act of liberation. Just before the final collapse into a single black hole, a complex gravitational interaction between the last few remaining objects could act as a cosmic slingshot. In this scenario, the remaining neutron stars and black holes are flung outward in all directions, ejected from the system at hypervelocity. The result would not be a single dark monarch, but a scattered, high-speed star cluster, a ghostly fleet of stellar corpses fleeing the scene of their own catastrophic history, forever destined to wander the galaxy alone. The system's beautiful, terrifying chaos ultimately consumes itself, leaving behind only the most extreme remnants of its violent past. 50 discoveries later, the view from this celestial storm is forever changed. We have witnessed stellar zombies, phantom atmospheres, and gravitational memories etched into chaos. We have seen how these 14 suns warp space into a broken lens, accelerate particles to impossible energies, and perhaps even hide cracks in the fabric of physics itself. Each strangeness is a direct challenge, a cosmic gauntlet thrown down before our understanding of how stars live, die, and shape the universe. These systems are not mere curiosities, they are extreme laboratories where the rules are rewritten. They force us to question the very stability of planetary systems, the timeline of stellar evolution, and the delicate conditions needed for life to arise. The existence of a single Quattuordecuple star system proves that the universe's imagination is far greater than our own, capable of architectures of breathtaking complexity and violence that we are only beginning to decode. The map of physics is not complete, and these stellar families are holding the pen, drawing in the missing pieces, so we turn this final question over to you. Out of these 50 mind-bending revelations, which one reshaped your view of the cosmos the most? Was it the synchronized stellar heartbeats, the river of fire flowing in a perfect circle, or the ghostly pull of an unseen crack in reality? Share your thoughts in the comments below, and if your curiosity for the universe's deepest mysteries is as endless as the void itself, subscribe to continue this journey with us into the great unknown.